Secondary station is under the control of the primary station. It can only send the transmission if it gets a command from the primary station. Otherwise, it cannot initiate a data transmission. So it issues response to the frames which it gets from the primary station. That is the secondary station. And then the third one is the combined station. So a combined means it is there's no meaning for a primary and a secondary here, whereas the combined station can perform both the command transmission and responses. So it combines the features of primary and the secondary stations. So these are the three types of HDLC stations. And then based on the types of stations, the link configurations can be divided into two things. One is the unbalanced configuration and another one is the balanced configuration. In unbalanced configuration, there is one primary station and more than one secondary stations. So, whereas in the balanced station, if both the ends, if there is a point-to-point connectivity between two ends and the two ends are a combined station, then at that point it is called as a balanced configuration. In both the types of link configuration, full duplex and half duplex is possible. Next, the types of transfer modes. So, based on the type of link configurations, that is whether it is a balanced or an unbalanced configuration, the data transfer or the frame transmission can be divided into three ways. First thing is the normal response mode, and the normal response mode, it is called as the term response. So there is some response to a particular command. So here comes the unbalanced configuration. So in this case, the primary can only initiate the frame transmission. The secondary will do a transmission after it gets a command. So it will send a response to that particular command, and that process is called as the command issuing the command. That process is called as the poll function. It is used in the multi-drop lines, and here the host will be the primary station and all the terminals will be the secondary station. The second transfer mode is the asynchronous balanced mode. As the name tells, balanced. So now coming to the balanced configuration. So both the ends are a combined station. Then only we can achieve the balanced configuration. So in this case, any station can start a transmission anytime without the permission from any other stations. This is the most widely used station since because it avoids the usage of polling and final bit because that causes some additional overhead before the frame transmission. So that is why this is the most widely used mode. And the third one is asynchronous response mode. So here also comes the response. So there will be a command and equivalently there is a response. So here comes the unbalanced configuration, but it is an asynchronous response mode, which means one unique feature is being added along with the unbalanced configuration, which is the secondary can also initiate a transmission without permission from the primary. So usually in an unbalanced, the primary can only start the transmission, but in this case, the secondary can also start a transmission. But the primary is usually the primary will be responsible for few features. So here also the primary is responsible for connection establishment, disconnecting, error recovery, and initialization. Whereas this asynchronous response mode is been very rarely used. So thus we have three types of HDLC transfer modes, which is the normal response mode, asynchronous balanced mode, and asynchronous response mode. Then coming to the frame structure, yes, HDLC supports the synchronous transmissions and all the transmissions should be prepared. The frame should be prepared and sent. And the data link layer's work is framing. It has to prepare the frame and encapsulate and send it to the transmission channel. So this HDLC, it supports a single frame format for all the data as well as the control exchanges. We'll be learning about the frame structure in detail now. So this is the frame structure